Hey, hello everyone. Welcome to the next video on basic electrical engineering. Today we are going to discuss the short question and answer on series and parallel AC circuit. I'm Ganesh from Kekewag Institute of Engineering Education and Research, Nashik. Welcomes you in this session. What is the learning outcome of today's session? At the end of this session, the learner will be able to solve the small numerical based on series and parallel AC circuit. Okay, so let's begin with the first numerical. So this is the common data for the question 72 to 74. Here you will observe that the voltage V is equal to 100 sine omega t plus 30 is connected across the pure resistance of 10 ohm. So here the maximum voltage is what? 100. So I want to determine the equation of the current. So equation of the current is always, please keep in mind, it is Im sine of omega t plus or minus phi. This is a standard equations you should remember. I is equal to Im sine omega t plus or minus phi. So I will calculate the Im. Im is equal to Vm upon R. So Vm is given as 100. So this is voltage standard equation is what? Vm sine omega t plus or minus phi. In this case, this phi is equal to 0 and Vm is equal to 100. So 100 divided by R, that is 100 divided by this 10 ohm resistance, will give you 10 ampere current. So Im is 10. Okay, so what is the phi angle in this case? It is a 30 degree. So in this case, phi angle is a 30 degree. So keep in mind, in case of pure resistance, current and voltage are in phase. So whatever is the angle, whatever the angle of the voltage, same will be angle of the current. So Im sine omega t plus phi, phi will be here 30 degree, same as the voltage angle. So 10 sine omega t plus 30. So if you draw the phasor diagram, so voltage will be on this phase, that is 30 degree, and the current will be also on the same phase with this angle 30 degree. Okay, so voltage and current both are leading to the reference by 30 degrees, but the phase angle difference is 0. Hence the cos of 0, the power factor is given by unity. How we will calculate the phi is equal to angle of voltage minus angle of current. So 30 minus 30 is 0. So power factor is unity. How will calculate the active power? Active power is equal to VI cos phi. But this VI and I should be RMS value. So RMS value is maximum value upon root 2. So 100 divided by root 2 into 10 divided by root 2 into 1. So it will give you 500 watts. Same can be verified through the I square R. I is the RMS value, 10 divided by root 2 square into 10. So R value is 10. So it will give you 500 watts. Same you can tally through this. Let me launch the next question. In this question, this is the common data from the question 75 to 77. Here, the voltage is given as 100 sine 2 pi ft plus 30 degree, and it is applied to the pure inductance of 0.1 Henry. So what is the value of Vm over here? Vm is what? 100. Vm is what? 100. And XL is equal to, so if you compare this equation, so it is the 2 pi f t. So here if you compare this, frequency is 50 hertz. So we know that the inductive reactance is equal to 2 pi fl. So 2 pi into 50 into 0.1. So inductance is given as a 0.1 Henry. So XL will give you 31.42 ohm. So how will calculate the Im? Im is equal to Vm upon XL. So keep in mind, here it is not L, it is XL. So 100 divided by 31.42, the current will be 3.183 ampere. So but we know that in case of pure inductor, in case of pure inductor, the voltage current is lagging to the voltage by 90 degree. So voltage is the plus 30 degree. So voltage is at the plus 30 degree. So the current equation is Im sine 2 pi ft plus 30. The same equation is appearing here, but I am adding the minus 90 into that because the current lags to the voltage by 90 degree. So plus 30 minus 90 will give you the plus 60. So here you will observe that the current angle with respect to the reference, it is the minus 60 degree angle. So 2 pi 50 t minus 60 degree angle. So phi is equal to minus of angle of voltage minus angle of current. So angle of voltage is 30 and angle of current is the minus 60. So 30 minus minus 60, it will give you 90 degree. And the power factor cos phi is equal to cos 90. So cos 90 is what? 0 lagging. Now I want to calculate the active power consumption. So active power is given by VI cos phi. So V is 100, I is 3.183. Okay, so these are sorry, it is 100 by root 2, and this is also divided by root 2, 3.183 divided by root 2, because we require the RMS value over here, and multiply it with the 0 because power factor is a 0, cos of 90 is a 0. So it gives you 0 watt power consumption in case of pure inductor. Let us discuss the next question. In the next question, the pure capacitance is given of the 0.1 millifarad. It is connected across the sinusoidal supply of 100 sine 2 pi 50 t plus 30. So 2 pi 50 t plus 30. So frequency is what, 50, and the Vm value is what, 100. So first we will calculate Xc. Xc is equal to 1 upon 2 pi Fc, that is ohmic value of this capacitance. So 1 upon 2 pi Fc, so 1 upon 2 pi into 50 into 0.1 millifarad, that is 0.1 into 10 raised to minus 3, it will give you 31.83 ohm, and Vm is 100. So how to calculate the Im? Im is equal to Vm upon Xc. So Vm is 100 divided by 31.83, the current is 3.142 ampere. In case of pure capacitor, the current leads to the voltage by 90 degrees. So I am writing Vm is replaced by Im, sign is as it is, 2 pi 50 t plus 30 is also as it is, but I am adding the plus 90 as the current is leading to the voltage by 90 degree. So 30 plus 90, it will give you plus 120. See, voltage is leading by plus 30 degree to the reference, and the current is leading to it by the 120 degree, and the phase angle difference between the voltage and current is maintained at the 90 degree. So phi is angle of voltage minus angle of current. So 30 minus 120, it will give you minus 90. So the cos of minus 90 is 0. Obviously it is a capacitor, it is written as a 0 leading. So how will calculate the active power consumption? Active power consumption is equal to Vi cos phi. So 100 into 3.142 into 0, so it will give you 0 watt power. Okay, so this is what pure R, pure L, and pure C when it is connected to AC supply. Now we will see the combinational problem. See, this is the common data from the question 51 to the 57. A resistance of 5 ohm and inductor of 0.01 Henry is connected across the 100 volt 50 Hz single phase AC supply. So resistance of 5 ohm and inductance of 0.01 Henry is connected across the voltage. This is the RMS voltage given, because equation is not mentioned, means this is the RMS voltage, and the frequency is given as the 50 Hz, and resistance is 5 ohm, inductance is 0.1 Henry. So first we will calculate the inductive reactance. So inductive reactance is equal to XL is equal to 2 pi FL, 2 pi into 50 into 0.01, so it is give you 3.142 ohm. How will determine the impedance? Impedance is equal to R plus JXL, that is R is 5 ohm and XL we have calculated is plus J 3.142 ohm. So how will calculate its this is in the rectangular form. So how will determine its polar form? To determine the polar form, we know that when there is a real plus imaginary value, so to convert into magnitude and angle, it is a square plus b square at an angle of tan inverse of a by b. So this is the equation to be used over here. So 5 square plus 3.142 square at an angle of tan inverse of imaginary value divided by real value. So this will give you the impedance 5.905 at an angle of 32.14 ohm. So this is a plus, it is indicates that it is the RL circuit. Now I want to calculate the current. So current is equal to V by Z. So V by Z means 100 at an angle of 0. We'll taken the voltage as a reference, divided by 5.905. This is the polar form which I have taken over here. So this is the polar form which we have determined. So that is taken in the denominator. So 100 divided by 5.905 give you 16.93, and the 0 minus 32.14. So I have discussed this during the AC fundamental lectures. So in my playlist you can observe this AC fundamental video, and from that you can refer the phasor, how to calculate the phasors and phasor manipulations or multiplication. So it will give you 16.93 at an angle of 32.14. Now I want to convert it into rectangular form. So to convert into rectangular form, magnitude is taken here and multiply it with the cos of angle. So cos of angle is minus 32.14 plus j sine of angle is minus 32.14. So according to the Euler's identity, and if you calculate this will give you in terms of this real plus imaginary value. So you calculate this and comment me in the chat box what is the value of the current in the rectangular form. Okay, the power factor of the circuit is, so I will calculate the power factor. Cos phi is equal to angle of voltage minus angle of current. So angle of voltage is 0 minus angle of current is minus 32.14. So it will give you 0.186 lag. That this same can be verified through R by Z. So R is 5 and Z is 3.915. So 3.905. So it will give you 0.846 lag. Why it is a lag? Because it is RL circuit. Now I want to calculate the active power consumption. So how will calculate the active power consumption? P is equal to VI cos phi. V is 100, I is 16.93, cos of 32.14. So it will give you 14.32 watt. Same can be verified through the I square R. So I square means 16.93 square into the resistance value is R. So it will give you 1433. Approximately these two answers are equal. Similarly, the reactive power consumed by the AC circuit is Vi sin phi. So V is 100, I is 16.93 sin 32.14. So it answers gives you 900.6 VAR. Same can be verified through I square XL. So Q is equal to I square 16.93 square into XL is 3.142, which we have calculated here. So it will give you 900.6 VAR. The apparent power consumed, it is only VI. So 100 into 16.93, that is 16.93 VA. Same can be verified through I square Z, that is 16.93 into 5.905. So it will give you 1692 VA, or same can be calculated as P square plus under root P square plus Q square, because in the power triangle diagram, this is the P, this is the Q, and this is S. So suppose according to the Pythagoras rule, so S square is equal to P square plus Q square. So by this way, you can calculate the value of S. Okay, hope you understood this numerical, which is based on the RL circuit. Let us discuss the next numerical based on the RC circuit. So here, what is the given? The resistance of 5 ohm and inductance of one capacitor of 1 millifarad is connected across the 100 volt 50 hertz single phase AC supply. So voltage is 100 volt, frequency is 50 hertz, resistance is of 5 ohm, and the capacitance is of 1 millifarad, which are in series. So now we want to determine the different quantities. Okay, so first we have to determine capacitive reactance. Capacitive reactance X is equal to 1 upon 2 pi Fc. So it is 1 upon 2 pi 15 to 1 into 10 raised to minus 3. So it will give you 3.183 ohm. So how will calculate the impedance? Impedance is equal to R minus jXc. So it is 5 minus j 3.183 ohm. So why it is a minus jXc? Because it is the capacitor over here, so it is a minus jXc. So if you convert this is the rectangular form. Suppose you convert into the polar form, under root real value square plus imaginary square tan inverse of minus 3.183, because x is minus over here, so minus 3.183 divided by 5. So this will give you in the polar form, that is this one is in the polar form. Okay, so this is also in ohm. So now I want to calculate the current. So current is equal to V divided by Z. So I is 100 at an angle of 0, and Z is 5.927 at an angle of minus 32.48. So 100 by 5.927 will give you 16.87 plus 32.48 ampere. So you can convert, this is the polar form. You can convert this convert this into rectangular quantity by taking the cos of theta plus j sine of theta. So according to the Euler's identity, and then you can convert it into the rectangular form. So this is what in rectangular form answer. How will calculate the power? Power factor is cos of angle of voltage minus angle of current. Angle of voltage is 0 and angle of current is 32.48. So cos of minus 32.48 is 8.44. How will calculate the active power? Vi cos phi. V is 100. I, we have calculated, it is I. Magnitude of I is 16.87. Magnitude of I is 16.87 into cos of 32.48. So it gives you 1423. You tally with this equation also. P is equal to I square R. So you substitute the value of 1.87 square into R value is what? 5 ohm. You calculate it, and you can cross check with this. This is the same value. Then it is a Vi sin phi. Sin phi value is what? Minus 32. So if you observe here, the phi value is what? Minus 32. Angle of voltage minus angle of current, phi value is 32. So it is sign of minus is will give you the minus sign. So Vi sin phi, it is minus 905 VAR. You can tally with this I square XC also. So you can put the value of I square and XC. Why this is a negative sign? Because capacitance supplies the reactive power. Capacitance what? Supplies, not absorb, it supplies the reactive power. Hence it is the negative sign. Q also can be calculated using the relation P tan phi using the power triangle diagram. Apparent power S is calculated as V into I. So 100 into 16.87. So it will give you 1687 VA. Same can be verified through I square Z, or same can be calculated through the P square plus Q square. Okay. So hope you have enjoyed this small numericals based on the RLC circuit. We will meet in the part 2 video for the numericals on the resonance circuit. Thank you.